Today we're here to walk you through how we use Python libraries to clean and analyze global aviation data. So we began by importing necessary libraries such as pandas and NumPy. Then we defined the column names for each data set for airlines, airports, and route data sets. Next, we loaded our data sets and we handled all information with /n and handled them as none. Next, we inspected our data and checked for missing values. So we use this now to check for missing values, and we use sum to calculate the total missing values we had in our data sets. We converted our numeric columns to appropriate data types, for example, latitude and longitude, and we checked for duplicates in our data set as well. We then went on to get rid of all duplicates in our data sets, and we handled missing values for IATA and ICAO. We replaced all missing values with unknown, and we went on to verify our data types and our missing values after cleaning our data. What I went on to do next was filter out invalid latitude and longitude values. So for latitude, all values outside the range of -90 and 90 were gotten rid of, and for longitude, outside -180 and 180 were also gotten rid of. We printed our new information and we went on to provide a visual representation of our data sets. So we used bar charts to represent top 10 countries by number of airlines, distribution of airports by country, top 10 source airports. And next, we went on to provide a summary statistics of our data sets.
So after getting cleaned data and some visualizations to represent them, we then created a global aviation network dashboard using Python and Streamlit. So from analysis, we discovered that there were thousands of routes and airports, and we were able to uncover some key insights about them, their airline network, geography, and market competition. So we have 5 tabs on our dashboard. The first tab is the Overview tab, and this represents a summary of the statistics of over 7,500 airports and 6,000 airlines and over 67 and almost 67,000 flight routes. And we also displayed the top 10 hub airports based on their connectivity using network centrality. We also have another tab, it's called a network tab. And basically this network tab is just providing some network analysis. And here we are visualizing the global aviation network as a graph. Airports are represented as nodes. These nodes are colored here in different colors, and the node sizes and these colors reflect the centrality. That is how concentrated these airports are at specific places. And this is to help us detect the most influential hubs in the system and potential vulnerabilities they may have. We also have a geography tab, and this is for geographic analysis. So here we have a map of the airport density by country, and we're able to achieve this using Folium, using Python. This is showing us how well certain regions are connected and which ones are under-deserved. So the colors here are displaying the total number of airports here. We also have a business tab, and this is for business intelligence, and it's to help us answer certain questions that we may have about the entire global aviation space. And here we have a graph showing us the airlines, certain routes they've covered. So for example, you can see that Ryanair here, which is an American-based airline, has almost 2,500 routes counts, and United Feeder Service has a little over 1,000 routes counts. And a Chinese airline here, China Southern Airlines, has close to 1,500 airlines. So this should tell you some information, gives you given insights on certain things in their markets, in the airline space. We also discovered that there were just 20.3% active airlines in the entire global aviation space. We also have a search tab, though this is to allow potential users to find the shortest path between airports. So for example, if you want to find the shortest path between JFK and HND, you enter the IATA code of these airports, and you enter the IATA codes for the source airports and destination airports, and this will give you the shortest routes and also give you some insight on the total number of stops you have to make using these shortest routes. So this here is our global aviation network dashboard, which you're able to put together using Python and certain other models and libraries based on the clean data we had from our earlier cleaning and analysis process. Thank you.
OOP is a programming paradigm that structures code around objects. Each object combines both data, which are attributes, and behaviors, which are methods. Each class has its own responsibilities, which makes code modular, reusable, and easier to maintain or expand. The OOP approach for our Canvas Lite projects makes it simple to build features like role-specific dashboards, notifications, and simulates real-time communication while keeping the system scalable. Beginning by registering as a student, our system requires every user to provide an 8-digit ID, full name, email address, and a secure password. For students, the ID must end with a valid academic year, anywhere between 2020 and 2028, which helps us identify the user role based on the format of their ID. Once the form is submitted, our backend validates the inputs. The validator checks if the ID follows the correct format and if the password meets all the required criteria. If any of these checks fail, the user gets an error message. Once validated, the password is securely hashed using bcrypts. This means we won't store raw passwords, only a hashed version of the user's JSON file, making it much safer in case of a data leak. After registration, you log in as a student. The system retrieves the user's data from user's JSON and compares the entered password with the stored hash using bcrypt's built-in check. If it matches, the system logs the user in by storing their ID in the session. It then checks the last 4 digits of the ID to determine the role. If it's a valid year, the user is a student, and we redirect them to the student dashboard. For faculty, the process is very similar, but here the ID must end in 4 zeros, which is how the system recognizes faculty members. After logging in, users are redirected to role-specific dashboards. For students, the dashboard displays all their assignments for the courses they are enrolled in, along with due dates and submission statuses. For faculty, the dashboard offers tools for creating assignments, sending messages, and posting announcements. The system uses Flask sessions to maintain user states. The ID is stored in session user, and their role, either student or faculty, is used to determine which dashboard HTML templates to render. When rendering the dashboard, the app fetches the full user object from the JSON file using the helper function. The student dashboard dynamically pulls assignments for the students' enrolled courses using their course list. It also integrates the submission class to check if each assignment has been submitted and displays status indicators accordingly. On the faculty side, the dashboard loads only the courses where the faculty member is the instructor. From there, the user can create assignments, view submissions, and send announcements. From the faculty dashboard, instructors can create assignments using a form that takes in the course, title, description, and due dates. Once submitted, the form sends a post request to the create assignment route. This route instantiates an assignment object, generates a unique assignment ID using UUID, and stores the assignments in the assignments JSON file via a created method. Each assignment is associated with the course ID, ensuring that the students only see assignments for courses they are enrolled in. Faculty can review the assignment they've created by visiting the assignment detail page, which is rendered using a template which pulls all relevant assignments info from JSON storage. On the student's dashboard, each assignment card has a link to a detailed assignment page. This page includes a submission form where students can upload their answers or page responses in the text area. Instead of storing submissions inside each assignment, they are stored globally. The app uses helper functions to fetch and display the relevant submissions. Faculty can view all student submissions for particular assignments through the View Assignment HTML templates. Behind the scenes, the route fetches all assignments matching a given assignment ID. Once submissions are listed, each comes to the grading form. Faculty can enter a numeric score and submit it. The Flask route captures the grade, updates the grade field of the corresponding submissions JSON, and then saves the changes. Students will see the graded submission reflected in their inbox. Most students and faculty have access to an internal messaging system accessible through the inbox link. Messages are stored in messages.json, each having a sender ID, recipient ID, subject, content, and timestamp. The system uses the message class to handle loading and saving. Users can compose and send messages from the inbox page. Incoming messages are filtered by checking if the current user's ID matches the message's recipient's ID.
In
And the
summary,
Flask Socket IO
we
enables
developed two
real-time message
Python-based
alerts, so
projects,
users are
a
notified of
Canvas
new changes
LMS
instantly
Lite
without needing
and a
to
Global
refresh.
Aviation Network Analysis Dashboard. Our Canvas LMS Lite, as you saw, was basically a lightweight learning management system that supports role-based access, assignment workflows, analytics dashboards, and simulated communication built with usability, security, and scalability in mind. Our Global Aviation Network Analysis Dashboard was basically a data analytics project that uses real-world aviation datasets to explore network connectivity, centrality, route patterns, and geographic distribution through powerful visualizations and interactive dashboards. Both projects demonstrated the application of data handling, visualization, graphic user interface development, and modular Python programming in solving real-world problems across education and aviation domains.
Hello, so this brings us to the end of our video. We hope you like, share, and subscribe.